All right, today we're going to dive into something that sounds a little bit like a magic trick. It's this mathematical rule about how adding opposites can leave you with, well, absolutely nothing. It seems simple, right? But it has some seriously powerful consequences.
Yeah, I know. It sounds kind of like a riddle, doesn't it? I mean, if you add something, you should have more, not nothing. So, how does that even work? Let's break this whole puzzle down piece by piece. So, instead of throwing a bunch of complex formulas at you, let's start with something we can all relate to, a simple video game. You know, the kind where you earn and lose points. Okay, so let's meet Neva. In her game, she has a great first turn. She scores 3 points, awesome start. But then, on her very next turn, bam, she loses all three of them. So the big question is, after those 2 turns, what's her score? To really figure this out, let's make it, tangible. We're going to use this really simple but surprisingly powerful tool called integer chips. It'll let us see exactly what's going on with Neva's score. And look, the tools here are super simple. We've got these positive yellow chips, each one is worth +1, and then we have these negative red chips, and you guessed it, each is worth -1. That's literally all we need. All right, so after Nova's first turn, this is what her score looks like on our board. 3 of those positive chips. That gives her a total score of +3. Pretty straightforward, right? But then, remember, she loses 3 points. Now here's the interesting part. In our model, that means we actually add 3 negative chips to the board. So the math expression for this is 3 plus -3. Okay, so this brings us to the key question. We've got positive chips and negative chips, all sitting there together. What do you think is going to happen when we pair them up? Well, the answer to that question, it leads us right to the core idea of this whole thing, which is the incredible power of zero. See, when you take one positive chip and one negative chip and bring them together, they form what's called a zero pair. And the name kind of gives it all away, right? Because +1 and -1 are perfect opposites. They just completely cancel each other out. Their combined value is just 0. Okay, so let's go back to Neva's score. We've got 3 positive chips and 3 negative ones. So what can we do? We can match them up 1 to 1, and that gives us 3 of these zero pairs. And as soon as they're paired up, poof, they neutralize each other. So after all those pairs cancel each other out, what's left on the board? Absolutely nothing. A big, clean 0. Neva's score is right back where she started, at 0. You know, this zero pair idea is actually so important that it has an official math name, additive inverses. Don't let the fancy term scare you. It's just the formal way of saying you have 2 opposite numbers that whenever you add them together will always bring you back to 0. Okay, so the chip model is a great way to see this. But you know what? There's another really powerful way to visualize it. Let's take a look at how this exact same idea plays out on a number line. Let's try a new example here. How about 5 plus -5? Now on a number line, you always start at 0. First step, we move 5 units to the right for that +5. Okay, now we're at 5. From that exact spot, we add the -5, which just means we move 5 units back to the left. And where do we end up? You got it, right back at 0. See, it doesn't matter if you're using chips or a number line, the result is exactly the same. Adding an opposite always brings you right back to where you started. It's just such a perfect way to visualize it. I mean, think about it like this. You take 5 big steps forward, and then you take 5 big steps back. Of course, you're going to end up right where you started. So, just to be super clear, what exactly are opposites in math? Well, they're just 2 numbers that are the exact same distance from 0, but on different sides of it, like 2 and -2. Or 10 and -10. They're basically perfect mirror images of each other across that 0 line. Okay, so this all works for video game scores and for number lines. That's cool, but why does any of this really matter? Well, because it turns out this simple idea of balance isn't just a math trick, it's a fundamental principle of how our entire universe is built. Now, this is where it gets really cool. Think back to our little positive and negative chips. Well, in chemistry, you've got protons with a positive charge and electrons with a negative charge. It is the exact same one-to-one relationship. It's incredible.
A stable, neutral atom is a perfect real-world example of what we've been talking about. It has the exact same number of positive protons and negative electrons. And just like our chips, they form zero pairs that cancel each other out, giving the whole atom a balanced, neutral charge of, you guessed it, 0.
So here's the real crucial point, the main takeaway. Adding an opposite isn't really just about subtraction. It's an act of neutralization. It's about bringing things back to a state of balance, back to 0. So if there's just one simple rule that ties everything we've talked about together, it is this. The sum of any number and its opposite is always 0. No exceptions.
I mean, think about it. From video games all the way down to the atoms that make up our entire world, this principle of balance is just everywhere. So, I'll leave you with this question to think about. Where else in your own world do you see this powerful zero-pair idea in action?